Okay, so now we're going to actually do some problems, and you'll notice always read the directions, solve the equation, and answer in set notation. So let's start here. Now, if I see fractions, I can deal with them. Fractions don't scare me, but I do like to get rid of them. So remember we talked about clearing fractions by multiplying times the least common multiple. I see that 2 and 3 are the denominators. That means what I can do is multiply everything by 6, which is 2 times 3, and then those fractions just magically go away. So I'm going to multiply both sides by 6, distribute that. So 6 times 1/2 x is now 3x, plus 6 times 4 is 24. 6 times negative 2/3 is negative 4x, and 6 times 1/2 is plus 3. So now I have a nice equation. I need to get the x's on the same side. I need to get the numbers on the same side. So if I were you, the next thing I would do is I would add 4x to both sides. And while I'm at it, since this is going to go away and I'll have x's here, then I need this to go away also. So you could even do it in the same step as long as you're careful. This gives me 7x. This is now 0. This is now 0. And this gives me minus 21. So if I divide or undo the multiplication by 7, I divide both sides by 7, and I get x equals negative 3. So that's my final answer. In set notation, it looks like that. Second example. If I can zoom in a little, it should be okay. You should be able to zoom in. So this just looks like a straight distribution problem. I'm going to distribute the 3 to the x plus 5, so I get 3x plus 3 times 5. And this looks exactly the same on both sides. So if I took away 3x from both sides, and I took away 15 from both sides, right? To make at least one of them go away, well, I'm going to get 0 equals 0. Okay? And that is true all the time. If it's true all the time, then that means that x can be anything. And so if x can be anything, then the set of all x's such that x is an element of the real numbers is what we would write for our set. Third example. Again, we're going to do a distribution problem, and we're going to solve for x. So we're going to distribute that negative 2 over here. We're going to distribute the 6 here, and we'll just add stuff together when we can. So this is negative 8, plus negative 2 times negative 3x is 6x. We still have a 7 there, and now it's equal to 6 times x plus 6 times 1. So first thing I'm going to do is combine these like terms. And then I'm going to take away 6x from both sides. Well, look, we get negative 1 equals 6. That's not true. That's never true. So because that's not equal, it's possible to get no solution. And so because nothing for x will make that true. So the way you write no solution as a set is like this. Empty set. Some teachers will have you put like a 0 in there, but it has to be null. So it has to have a slash with it. That's called a null set. And these are our 3 solutions. So you've got an example of no solution, all solutions, and one solution, which we're going to talk about a lot in the next section. So these notes here, one is a visual representation. This is a geometric definition because we have to talk about absolute value. Absolute value is